Lesson 5 we're going to look at today is on factoring expressions. This is basically the opposite of what we did when we distributed. It's kind of like working in reverse. Like we already distributed, now let's back up and see where did we start from before we distributed. So the question is, how does the distributive property relate to factoring expressions? And we will find out today. So example 1, Kiana painted a rectangular wall blue to start an ocean mural. She used 3 cans of paint, each of which covered X square meters, and a different sized can that covered 12 square meters. What are the possible length and height dimensions of Kiana's mural? Okay, so there's a couple different ways we can look at this. The first way, the book's talking about it, making an area model. You can look at that. I guess it depends on what kind of learner you are. Maybe that's more of a visual type learner. I have a hard time looking at that to figure that out from what we were given. So I'm going to go look at this another way, and then we can talk about that other option there later if we want to. So basically the first part, it says 3 cans of paint, each covered X square meters. So if we talk about how many square meters we're covering, 3 cans of paint, X square meters for each can, that'd be 3 times X would tell me how many square meters we covered. The other thing, it told me it was a different size can. It covered 12 square meters. So that's where they got the plus 12. So we've got 3x plus 12 square meters that were painted all together. The question is, what are the dimensions? Well, if we have a rectangle, the dimensions they're referring to, if you have a rectangle, is that we have a length and we have a width. So the length and width would be our dimensions. When you find the area of something, when you get square meters, for example, you multiply the length times the width. So right now I'm looking at 3x plus 12. Well, there's 3 times an x, but then it's plus a 12. I don't have something times something for that area. So that's what I want to figure out. What times what is going to give me 3x plus 12? So what we can do actually is going to boil down to this final step here. Basically, we're looking at our numbers, the 3 and the 12. We're looking for what they have in common. We're actually looking for the greatest common factor we've talked about. So 3 and 12, the biggest number I can divide both of them by would be 3. And then the question is, if I divide them both by 3, what am I going to be left with? So if I factor out a 3, as it's called, what am I going to be left with? If I would distribute, that would give me 3x plus 12. So 3 times what to get 3x? It'd have to be 3 times x, or 3 times 1x if you want. You can put a 1 there. And then 3 times what to get 12 would have to be 4. 3 times 4 equals 12. So that gives me something times something that equals 3x plus 12. So that tells me these could be my dimensions. So my width could be 3 meters, and my length could be 1x plus 4 or x plus 4 meters. Okay, again, for it being an area, we know we have to have 2 factors, 2 things multiplied together to get that. So it's a little bit weird for us to look at it first, maybe because we've got a variable. We're used to saying my length is 5, my length is 11. This one, a little bit different with the variable involved, but that's what we're looking at on that problem. So to try it, we have a similar example. Use factoring to write an expression for the length of the pool with the given width. Again, they've got a picture here for you. If that helps you, that's fine. Ultimately, we don't necessarily even have to have the picture in order to work this one out. We're looking at our numbers again, so 4x plus 20. So just looking at the numbers here, look at the 4 and the 20. We're thinking about what's the biggest number I can divide both of these by. In other words, what's my greatest common factor? And the biggest number that possibly could be would be 4. Okay, because that's my smaller number. That's the biggest number I could possibly divide. Can we divide 4 and 20 both by 4, that they would come out evenly? The answer is yes. Good. Okay, so what that means, that is my greatest common factor. That's the number I can factor out in front here. So if we factor this 4 out, this is the reverse of distributing. It's not a word, but undistributing, maybe we could call this. No, it's factoring is really the name for it. But so 4 times x, does that give me 4x? Yes? Okay. And then the next part is, the question is 4 times what? That's going to give me 20, which would be 5. So 4 times 5 equals 20. So we would put a 5 there. So we have the one dimension, we know by looking at the picture, the one dimension is 4 meters. So our other dimension would be x plus 5. Look at example 2. Rodrigo and Jordan each factored the expression negative 2x minus 6. Who factored the expression correctly? So, like we've talked about before, anytime they're subtracting, you have the option of adding the opposite. So if you want to change that to negative 2x plus negative 6, you can. Bless you. And then if we look at this, we look at how Rodrigo factored his expression. Again, if you want to add the opposite there, you can. So negative 2 times negative x would be negative 2x. And then 2 times negative 3 would be negative 6. So negative 2x plus negative 6. So that works. If we look at the other expression, they factored out a negative 2. Negative 2 times x is negative 2x. Negative 2 times 3 is negative 6. So that also worked. So technically they both are okay with how they factored this. Depends on the situation on what we would actually want to do here. If you look at this, looking at the one over here, if we actually did have a rectangle, if this was like what's the dimensions of the rectangle, does it make sense for us to have a width of negative 2? No, width can't be negative, so that doesn't work. So in a real life situation, sometimes that's not going to work. Sometimes we're just working something out and it's not necessarily always about a rectangle. So for the long term, just what's going to be helpful for you guys is this. If the first term is negative, usually it's best to factor out a negative number. It's not technically wrong if you don't factor out a negative number, but it's in the long term when you get into algebra and stuff, in high school especially, you'll just find out on some problems that that's going to make it a little bit easier for you to work the problem out at that point. So if we look at the try it, they want us to find 2 different ways to factor negative 4x minus 28. So if we're going to do this, if you want to, before you get started, if it helps you out, you can add the opposite here. Make it negative 4x plus negative 28. Like I said, long term, it's maybe going to be easier for us if we factor out a negative number. Ignore the negatives for a minute, but then see how that negative 4x, it is a negative number to start out with. So we may want to actually factor out a negative number with this one. So look at the numbers. Again, if you want to ignore the negatives, just think about 4 and 28. and think about what the biggest number is that we can divide 4 and 28 both by that would come out evenly. So on this, technically there's two different things we could factor. Would be either 2 or 4, ignoring the negative again for a minute here. Again, what's going to help you in the long term, the biggest number that we can factor out is what we want to do. So we're going to factor out a 4. Since it's negative, I'm actually going to factor out a negative 4. And we'll talk about in a minute what would happen if you didn't factor the negative out. So we're going to think about this now. So if we look at this, the negative 4, we're thinking negative 4 times what to get negative 4x, and then we're thinking negative 4 times what to get negative 28. So negative 4 times x, or 1x if you want, would give us the negative 4x, and then negative 4 times 7 would give us negative 28. This is one way of factoring this. Generally, I'm not going to be asking you guys to factor two different ways. This way would be fine. And again, that's going to be your best long-term answer. If you just factored out a 4, just to show you what your other answer would have been here, basically we're just going to have opposite signs here. So 4 times it would be a negative 1x. To get negative 4x, and then it would be 4 times negative 7. So either one of those would be fine. Again, with the directions they gave us, we would need both of those, but technically this first one would be the long-term solution that you'd want to find. One other thing, the second option here, just a slight variation we could do on that. We could do 4 times negative 1x. Minus 7 would be the same thing. Add the opposite, you'll see that those are equivalent. You look at example 3, it says use the greatest common factor to factor the expression, which is what we've been doing. The only variation here is that we have 3 terms instead of 2. So we just need to find something that actually works with all 3 of these. Again, if you want to add the opposites here, you can. We're looking at 6, 18, and 12. 6 being my smallest number is going to be the number I'm going to look for. So we're going to check. Obviously 6 divided by 6 comes out evenly. 18 divided by 6 comes out evenly. And 12 divided by 6 comes out evenly also. So all of those work. So 6 would be our greatest common factor. When we go to factor that out then, one way if you're having a hard time figuring out what numbers would go or what stuff would go in your parentheses here. One way of doing that is thinking about take your number you started with divided by your greatest common factor. So like my first number here was 6. So if we took 6 divided by 6, we would get 1. So that tells me I could put a 1x here, or just an x if you want. The second one we had 18, negative 18. So if you do 18 divided by 6 is 3. That's how they got the 3 here. And that would need to be negative. If you want to add the opposite on these, by the way, would be fine as well. And then 18 divided by, 12 divided by 6 would be 2. That's how they got the 2 here. Again, that would need to be a negative 2y for that to work out. So this would be our factored form for that problem. If we look at the do you understand number 2, Susan incorrectly factored the expression below. Explain any errors Susan may have made when factoring. So we're just going to look at this and see what happened here. So you can see that she factored out a 3. So we're just going to check what happened, whether there's any mistakes here. It says there are. Again, anytime there's a subtraction, if you want to add the opposite, you can. So we're just going to look one piece at a time here to see how this works. So let's think about 3 times 4a. Does that give me the 12a that we started with? Yes. Okay, 3 times 5b, does that give me negative 15b that I started with? No. What should it be? Negative 5b. They forgot their negative, so that's one mistake. Okay, see if that's all. 3 times 3, does that give me the 6 we started with? No. Okay, well, should be 3 times 2. So those would be the two changes that we would need to make for that to be factored correctly. If we look at the do you know how number 3, Sahil is putting together supply kits and has 36 packs of X pencils, 12 packs of Y crowns, and 24 erasers. Write an expression to show the total number of items. So if we have 36 packs of pencils, there's X pencils in each box. How many pencils do we have? Good. 36X, good. If we have 12 packs of crowns, there's Y crowns in each box. Allison? 12Y, good. And then if we have 24 erasers, Emma? It's just 24. Okay. Alright, so this would be our expression starting out. And then we're going to use factoring to show how many kits Sahil can make while putting every type of item in each kit. So we're going to factor this out. So we're just looking at our numbers here. And I'm going to start by looking at that smallest number, which is the 12. I'm going to think about whether all of those numbers are divisible by 12 or not. So 12 does work, so we're going to be factoring that out. And then we're going to think about what that's going to leave us with inside our parentheses. So 12 times 3x would give us 36x. 12 times 1y, or just 12 times y, would give us the 12y. And then 12 times 2 would give us 24. Now, it says showing how many kits Sahil can make. The fact that we were able to divide this by 12, everything was divisible by 12, that means that he actually made 12 kits. Sorry, 12 kits should be there. And then part C, use the factored expression to find the number of each item in each kit. So we can see the first part, we've got a 3x there. So that would represent we've got 3 packs of X pencils. The 1Y in this case is actually a good thing. Maybe we put the 1 there, might help us out to see that's 1 pack of Y crayons. And then we have 2 erasers in each kit. We look at number 5, how can you use the distributive property to factor the expression? They wouldn't need all the words here, they could just say factor, and that would be enough for us to know what we need to do here. So we're trying to factor, so we're looking at our numbers again, trying to see what they have in common. So with this one, the 6 and the 15 have a 3 in common. We can factor out. So 3 times what to get 6x would be 2x. 3 times what to get 15 would be 5. So this would be our factored expression.